So for Kickstarter for Europe, I was going to say, I was thinking about that the other day, what would be the options, or I know that there are people, like people from the UK have done Kickstarter projects. I think the only thing that really limits you to being in the U.S. is that you have to have a U.S. bank account.
Yeah.
So if you happen to be, like, I mean, me, I live here, I'm doing almost all the research here, and my company is founded in Seattle, but I don't think they actually care about that. It's just as long as you have a U.S. bank account that you can register with Amazon.com, then you can do a project. So maybe there's, maybe there is something that can be done, like Fabelier can, if you guys have someone that has some connections in the U.S., you can get a sort of shared U.S. account, and then people can do projects and route it through that.
Yeah, so I think it's only the trust that is necessary. So
yeah.
Of course, stuff like this was done also in Europe. So
yeah.
Some Blender.
Yeah.
It was also the same idea with the software. They created this foundation and then they collected the money. But yeah, if you announce, okay, I have this idea, I need money.
Yeah.
I think there are not so many people who
really?
take the money via PayPal or I don't know.
Yeah.
And I think that's the problem. There's no point of trust.
Yeah.
Often,
yeah.
And
yeah.
Of course, you can try to do it with an association. So somebody like the Kreis Computer Group in Germany, so they often help projects, or something like the Freifunk network.
Okay.
Also a community from, I think, from Berlin, which was very active with the OpenVRT and the mesh network. Yeah, but you have to find these people before, and often if you announce, okay, I have this idea, I would like to create a commercial product out of it. There's often this question, okay, you have a patent on it. Sorry, we are in open space, we are sharing each other, and you always have this problem that there are two ways of ideas not working really together, because of course it's nice to work with open source like arduino and sharing knowledge, but at some level you also have to pay your rent and apartment and
And French don't have good relationship with money. Because in one sense it's like fun for US people. If you speak about money, it's disgusting money.
Yeah.
You cannot speak about it.
Yeah.
Really.
Interesting.
It's a really strange relationship.
Yeah.
For example, you drop in a party, you say, I'm an artist, I'm a designer, people are very happy.
Yeah.
But if you say, I've been in a company, I will sell this, people will say, this guy wants to make money, he's not a cool guy.
Yeah.
It depends.
Yes.
The circle, yeah.
The circle.
That's a general opinion.
Since I was here, I also saw this. If you go to a party and they say, okay, you're an engineer or technician or something like this, okay. But when I say, okay, I'm doing light projections or I'm working with LEDs, with light, that's cool. But it's really like this. In France, when you're an artist, when you're creative, if you're doing music, the people think you're open-minded, but if you say you're an electrician or something, they think, okay, you are just people installers. Tons of cables.
Yeah. That's it. Yeah, that's very interesting. But I can definitely.
It's very common, in fact. Like there is the boss and the employees. The employees are just having fun or doing cool stuff, and the boss is very bad and just wants to make money. Yeah. The man of people is a lot like this.
Yeah. And in fact, that was actually I think one of the first. I don't know if it was on TMP or Fabelier. It was like one of the first things that I was encouraged to reply to on the mailing list, because people were talking about the copyleft, which was the first time I had heard that term, the idea of having everything open source and against copywriting and patenting and stuff. And for me as an inventor, patent is a very important thing. Practically, patents don't really offer you as much protection as people think they do, because they just give you the right to sue someone. You still have to find out who's infringing on your patent. You have to do that yourself, and then you have to have the money to actually take them to court and all these other things. Patents just give you a higher chance of winning the trial.
Money.
Yeah, if you have the money, exactly.
There's a big problem with patents. It's not really right.
What's that?
It's not just a right. You need to have the money
To file the patent, or
you
to...
don't have just to have the ID. You just have the ID and the money.
Yeah.
And
I mean...
to defeat it. To pay the lawyer.
Do you mean to actually get the patent, or to, like, to
get the patent.
Yeah. In the U.S., it's actually pretty...
If you want an
not too bad.
international patent, it's pretty hard.
For an international patent, it's extremely hard.
Just totally crazy.
Yeah.
It's just useful for a big company.
Yeah.
And too much company plays this game to, okay,
Yeah.
so we can make the...
Yeah. In fact, we have a patent lawyer in California that we work really well with. He's given us really great, for a startup like us, for just a couple of guys, his rates are really, really, really good. And he actually, on almost all of his cases, he's never seen it where it gets to the point where you actually have to file individual patents for the European countries, because the process takes so long for you to get to that point anyways, that a lot of that always ends up in the hands of a larger company, essentially, that ends up having to do that. So yeah, it is tough. Like, there is a difference. Like, for us at this stage, it's actually quite easy. I think it costs maybe $100 to file a provisional patent, and then you have patent pending status and stuff like that. You can submit a PhD thesis as a provisional patent with your pictures and all of these. They don't have to be a specific way. When you write the final patent, which you have to do within the next 12 months after that, then the pictures have to be according to a certain standard. It's a little bit more expensive to file the patent application, but even that is only maybe, I think, $200, $300 at most if you do it yourself. But that takes a lot of time. Like, you have to be pretty aware of all the things that need to go in there. You need to be very careful about how you describe your project, which words you use to describe your project, which you can, now over the past 2 years of doing this, filing patents like this, we usually do our patents by ourselves up to a certain point, and then we'll have someone else, we'll draw the pictures, either using our CAD software or by hand, and then we'll have a patent drawer redo them in the official patent standard. But after you get the patent, then you have to pay fees every so many years to keep the patent, which gets very expensive. And then if you have them in different countries, you have to pay fees on every single one of those patents. Every time, if you have a lawyer, every time someone, you get what's called action items. So someone will say, hey, we just found this other patent that was filed 20 years ago or 15 years ago that still exists, and it sort of conflicts with your patent. You need to do, this, and this to assess your patent. That costs money. The most expensive one is translation for each country. If you do it in the United States, then you have to translate your patent, and they charge by the word or something like that. It's actually quite expensive. So yes, you're right. It is. It's not just having the idea, you also have to have the money to continue to protect it. And there's a whole side.
For me, the worst program is patent.
What's that? Yeah.
That's the worst program.
Yeah.
Because I think ID can move totally freely, and patent is just useful to have money for an inventor. Yeah. But there's different program with that, I think it's not the same program with droit d'auteur.
Copyright.
Copyright, yeah. Yes, it's not really the same, but a little bit. Yeah. And I don't know, it's really a really strong program. Yeah. Because sometimes I think the knowledge is free, and so to invent some stuff, it's totally free, so everybody can use everything. Like in art, you are inspired by every stuff, and you don't give money to this for the singer or this other singer, you use but in another way, you have to eat.
yeah, exactly. Yeah.
And so
and no one, I guess it's quite capitalist, but no one has figured out a better way of incentivizing, motivating people to do these very sort of risky but creative things without some idea that they're going to be able to, you know, take care of their children or whatever it may be. Yeah, I think it's quite. For patenting, it's actually quite. I think it's quite interesting with the idea of it being free, because a lot of people, at least in the United States, a lot of people believe in the idea of a world patent, that you can patent something and it covers the entire world, which it doesn't exist. Yeah, you have to. They don't realize that you have to patent in every single country. No one does that. I don't think anyone has their device patented every single place in the world. Probably even Apple doesn't have it. It wouldn't make sense for them to, you know, patent their technology in this one place in Africa or something like that, because there's no one that is going to build it in Africa, and there's not that many people that are going to buy it in Africa, or this country in Africa. There's some countries in Africa, I'm sure they do have a patent, but, you know, country X in Africa. So there's no reason to have patent protection there, which means that if someone does figure out a really good way of building like the next Mac in that country, they're free to do so. They just can't sell it anywhere else but that country. And that goes along with the stuff that we do, even the technologies that we come up with, that we really want that to be focused on developing countries. We patent that. We patent it, and we patent it in the United States, and we patent it in Europe, because these are countries that can definitely afford to pay for it. They're countries where if there's an application in that country, it can create its own industry within that country. But we definitely don't patent it in Haiti. We don't patent it in Guatemala. So by all rights, it's completely free in those countries. It's not protected, and it's just free. It's a free idea for someone to come and build their own.
Do you have plans to put it open, like if people want to make their own block, they can develop?
Like for Bsquares?
Yeah.
I don't know. That was one of the things that I wanted to talk to people here about, because I'm not. Arduino is really the best platform that I know of that has really worked, and even for them, it's a little bit weird. Like we were trying to contact Arduino so that we could make sure that our distributor or our manufacturer in Hong Kong would get a license for Arduino, and so it would be an official Arduino, because we wanted to support Arduino. But apparently Arduino has so many distributors now that they've stopped giving out licenses for Arduino. So any Arduino that comes out now has to be our manufacturer. I think they either buy their official Arduinos from some other distributor that got a license before Arduino stopped giving them out, or they make their own Arduino and they have to call it like Cduino or some different name. Yeah, exactly. Yeah. So, which is fine. That's what Arduino had in mind. I think we may go with one of the distributors for the Arduino board. We still may go with one of the distributors that makes the official Arduino board, just to support that sort of community. In terms of the hardware of the squares, I don't know. I'm not sure what the business model for that would be, if there needs to be one, and I'm not sure how well it would work. I can see how Arduino works in the sense that people can easily make like rapid prototype circuit boards, and there's a lot of companies that will allow you in a very cheap way to make your own board, and you can get it shipped to you. But I'm not sure what the benefit will be of making the Bsquares completely open, because I don't see how people would be able to make them themselves. It would be super expensive for them.
So I think because you just had a very nice example with this Arduino, the Italian guys, and also your example with the free idea. So when I take, for example, the guys from NIC Resistor with the MakerBoard, so they just worked on the RepRap foundation, and they thought it's too difficult for non-mechanical people to build a MakerBoard or build a RepRap. So they just created from one idea which already exists, they created a version, a fork of it. It's open source. You can download the CAD files if you have a laser printer, and you can print out your MakerBoard. but how many people have a laser printer?
Yeah.
So they are not selling, they are selling their idea, but they are selling more or less the service to fabricate it, to make it.
Yeah.
And I think this community is getting stronger and stronger. When I moved here, I just heard about 2 MakerBots in France.
Yeah.
So the first one was mine, the second one was just built up by a person I just met them. And then in last October I was in the temp lab, and there was plenty of them. And it's nice to see that this idea is really spreading around, and there are also now some European companies starting to create their own modification of the MakerBot. And I think this community is getting much bigger, and also I think there's no person who's buying with batteries in the store who will copy the housing of it. But all the geeks, they want to create more. They want to have
something different.
Something different. You can provide them a solar module and the arduino module and this and this and this, and then they are asking for a temperature sensor. And this and this, and so it will not take so long until they take the measurement of the dimension and they put some magnets in it. There's no. The idea is brilliant, of course, but it's brilliant because it's so simple. And I think at least you should make something like a version with a little breadboard inside, or with a little PCB where you can solder your own connectors inside, so that you already give the people that don't have a 3D access to a 3D printer or to rapid prototyping, that they already can create their own modules.
So that's where we are now. I completely agree. That's at least the bare minimum. So if you go to our project page, we call it the proto board. So it's just a bare bone square with nothing in it but this PCB with the 2.54 millimeter holes, and you can put whatever you want in there, sensors and stuff. And the idea, so that's the idea, is we want it as flexible but also easy for, so flexible and useful for a person who, like my brother or my mom, they're not going to do anything different with it. They want it to do like what it's supposed to do right out of the box. So we want it to have that usefulness and simplicity. But at the same time, we want it so that the person who is curious and wants to take it apart, one, they can easily take it apart, so they can snap off the lid and take apart the frame and put it back together, and easily put it back together, which those two things are not always the same thing. So take it apart and put it back together, and it be structured in such a way that they can sort of develop their own platforms on the inside. Not only inside, so we'll get to this as well, but we're sort of, depending upon the success on Kickstarter, we're sort of expanding even more the flexibility of how it's structured, so that people can swap in and out things.
There's already an idea for intercommunication.
Right, exactly. So I think that at the very least is the bare minimum in terms of making it easier for people to sort of just making it open in that way. Because we definitely do want that community. Like you said, I think Sean and I have only touched a very small percentage of the different things that this can do. And I think I'm convinced that the really great ideas are going to come from other people that are playing with it and are spending more time developing it. And it would be a shame for those ideas to just get completely lost because there's no way for them to develop on the system. So whether or not it's Sean and I making it, one, easy for people to develop, and us sort of being very reactive to the various needs and wants of people. So the idea behind this, I don't know if you saw the website, but the idea is we have recipes, so different configurations. And this is sort of to motivate people not only to try and do new and creative things with the blocks, but to also share what these new and creative things are with other people. So it's sort of everyone's building a community around it, just like Arduino has a bit of a community around it where there's a free exchange of ideas of what you're doing with it. We envisioned more so that, this, like you said, the squares, the frame and the toes are pretty simple. They're sort of just a means to an end. So we envision that as something that if we can make it simple enough and we can make it cheap enough, it's just something that you buy, and then from there you create whatever it is that you want to create, and that is sort of the freedom of ideas. But we have to make sure that it's flexible to allow people to sort of do all the things that they want to do with it, and it's cheap. That's the problem that we're running into, is that I'm worried that if we made it completely open, see, I don't know the economics of open hardware, open source. So if we made it completely open, I'm worried about how that will prevent us from making enough money to manufacture in quantity so that the ones that we do sell straight from the shop are cheap enough for people that are not going to make their own. You know what I mean? I think there's...
I'm very confident because even for simple stuff like PCB, for example, Adafruit Industries, they make a lot of money because people buy from them the PCB because it's more easy to do than to make it at home. Even for a batch of PCB, you have to pay the shipping cost, you have to pay to wait for 1 week. You can order for maybe $2 less more from Adafruit store.
And also the time you are investing in spending, creating PCB. So PCB actually is not, if you buy bigger quantities, it's not the price, but all the time you spend to create and develop PCB. So this is the time which, for most people, I think it's not the idea. They perhaps also have the knowledge, or they know somebody who can make something, but they don't want to waste their time in inventing the wheel.
Especially if it's not your idea. If it's your idea, you want to spend time to develop it. But if it's the idea of someone, you don't want to spend time to try to do more things because it's not yours. So you buy it.
I think most of the arduino stuff works like this. So if there is one person who just had the idea to create a sort of motor driver board. I think guys from SparkCon, they just made a nice one. And then people are looking for motor drivers. Okay, I can make it my own. I have to invest X amount of hours to solder it. Perhaps I will burn it up because I just had one error inside. So most of them, I think, decide to buy the standard version and use it. And it's also what I think what's getting more and more important for this group, to have more or less these standard modules. For Arduino, you have the breadboard and you can make everything. You can make it your own. But if you want to have it more stable, then you just stack it together with the prefabricated modules.
I mean, maybe that is the model. I mean, I guess it would be slightly different from Arduino, because Arduino is completely the route of licensing. So they don't make their own boards. They just make their money, if I understand it correctly, they just make their money off of licensing to, like, for instance, SparkFun is probably one of their biggest, like, manufacturers of boards and stuff. Whereas what might happen with Bsquare is it could be open to everyone, but we also make official Bsquare boards for people that don't want to necessarily make their own. I need to.
Especially, for example, for a company, you cannot have distributor everywhere. Shipping cost is very expensive. So there's people who make it good because it's quite the product.
So should we start the official presentation? Is that okay?
Le mail comment? C'est l'ennemi, on avait dit comment?
C'est toi et moi. Contact, c'est toi, moi, Joachim.
Can you see that, or am I?
Perfect. I can.
Are those the video cameras?
Yes.
Yeah? Great. All right, so we're going to talk about Bsquare today. I'll give you a little overview about who we are. So we is myself, Jordan McRae, and Sean Frame. I'll give you a little bit of the insight of the development of Bsquares, and we'll talk about the current project that's going on right now, and then we'll go into a little bit of the technical details of the squares. I figured it'd be a little bit more of a technical crowd here. So we'll go into the technical details, and then we'll end on sort of where we see Bsquares going. So continuation of the conversation we just had about whether or not it's open hardware is the right fit, and especially what type of flexibility we intend on designing around. So my name is McRae. My background is in aerospace engineering, aeronautical, astronautical engineering. I focus primarily on underwater robotics. I founded a company called Octo23 Technologies. So there's our mission statement. We focus on innovating and inventing new technologies with a primary focus on clean energy, clean water, and technologies for ocean conservation. So underwater robotics that monitor coral reefs and things like that. Underwater communication are some of our interests. And then my colleague, Sean Frayne, who I've worked on many projects with. We've probably been working and sort of inventing things together for the past 10 years now, I guess. We met 10 years ago, and we met at MIT. We convinced MIT to allow us to start a hovercraft club at MIT, and we put together a proposal, and they gave us funding for it. So we made our own hovercraft that we got to drive around the Charles River, and that's my example of us sort of meeting, because that was the perfect way for us to sort of learn from the very beginning how to work together. So for the past 10 years, we've been working on similar projects, each time them getting more and more complex, to the point now where we can work from all the way across the world. He's in Hong Kong, I'm in Paris. We meet up every 3 or 4 months and have a really dense and strong group powwow, I guess you would call it, and we come up with all kinds of different ideas. So Bsquare is the byproduct of our last meeting in Hong Kong, when we got together, came up with a bunch of different good ideas, and Bsquare was one of the strongest. So Sean runs Haddock Invention. They also focus on clean energy, clean water, and he also has some inventions in green packaging. You can go to his website, my website, to find out more about those projects. So the timeline, you asked about the timeline before. We came up with the idea, having lunch in a Hong Kong noodle restaurant, passing back and forth napkins. The idea was we were working on a separate project on trying to build a better solar charger for solar charging batteries, rechargeable batteries. And we started coming up with this concept of modular systems, modular configuration using some sort of magnetic connector. Then by the next day, I would say, it was actually in fact that night, but we worked past midnight, so I'll say the next day, we had our first prototypes. So I'll play this video, and I'll just talk through this. Those are the 4 first prototypes that we had. It's hard to see there, but they're made out of this foam core material. There's a solar panel, a battery square. I'm pointing to the LCD square, so that's something that I just took out of an LCD temperature module. You can see on the corners there, we just bent back some steel and put 2 magnets on each corner, so that we have the north and south poles facing out. And there I'm putting them together, so now the solar panel is connected to that small lithium-ion battery, and I connected an LED. You can see the current from the battery is going through the module with the solar panel and getting to the light, but also at the same time it's powering the small LCD screen. So this was our first attempt to sort of figure out if what we had just written on that napkin would actually work, where we can move these modules around and still keep the plus and minus circuit configuration that we intended for delivering power to all of the different modules in that configuration. So the concept is, it doesn't matter how many modules you add to that. If you add them in the right way in terms of their polarities being correct, then they should all receive power. So about a week after that, we had our first CNC machined plastic frames. One of the engineers that works in our shop in Hong Kong, Angus, is really good on the CNC machine. We had some prototypes, a prototype of the steel toes that would go in the frame, and the plastic frame itself. About a week later, we had a more sort of refined variation of that. Now we had 3 of them to test out with solar panels inside, the battery, and the Arduino PCBs. We filed a provisional patent the 1st of March, which sort of gave us a little bit more freedom to talk to people about it, get better ideas in terms of what needs to go in there. 2 weeks after that, we had our second rev of the PCBs from Seed Studio, our partner in Hong Kong. And then a week after that, or a couple days after that, we had 20 units delivered to our shop in Hong Kong for these Bsquares. These are those 20 units, actually. These are the prototype units that we've been using. You'll see them in the video, and this is sort of what we put together to really finalize the idea. And then while I was here in Paris, after I got 10 of the units, Sean has 10 of them in Hong Kong, and I was able to take out, so this was a test of this ability for developers when they have their own squares and they have some brilliant idea of what they want to put inside it, how easy it would be to just take out what's in there already, or receive a square that doesn't have anything in it, or the proto board, like you mentioned, and develop their own system. So the iPhone square and the speaker square are actually things that I developed after the fact, just using the same sort of structure that we have here. And then we launched Kickstarter yesterday, or 2 days ago. So I'll just play this. I don't know if you've all seen it, but I'll play this promo video.
There's no sound?
So yeah, we can go over that video a little bit.
Very video.
What's that?
Very cool, the video with.
Thank you. Thank you. I haven't got sick of that song yet. I've listened to that song a million times now, and I still haven't gotten sick of it. So some tech specs for the squares. We came up with like I said, the first initial designs were 4 basic squares: a solar square, a battery square, an LED square, and then the Arduino square. Then 2 more were added to the list, the iPod square and the speaker square, and then actually there's a 7th, which is the proto square, which allows people to sort of develop their own B-squares. So the solar square, it's a 1/4 watt panel on the solar square, 60 millimeters by 60 millimeters. So it's a 1/4 watt at 5 volts, 50 milliamp output at its highest. And then we've also put in a diode in there so that when, if you have them in an array, one panel gets covered, it doesn't act as a load to the rest of the other panels, which is quite important for solar panels. The battery square, not really much to look at. It's all inside here. We're actually using very thin nickel metal hydride batteries. There's 3 of them, so that's 3.6 volts output. The ones that we have in here are different from these tech specs. The ones that we have in here are very low capacity. Probably any of you that have done any hardware work with batteries, the first question that comes up is why are we using nickel metal hydride? Because they have a much lower, for their size, they have a much lower capacity than say like a lithium ion battery. Our main reason is because one, they're safer. Lithium ions, they can explode if you short them, whereas nickel metal hydrides don't have that same tendency to explode. They'll just, they degas. And then they're also much better, nickel metal hydride rechargeable batteries, much better for the environment than a lithium ion chemistry. So we sort of made the trade-off to use those batteries instead of lithium ion. But we knew there were going to be a lot of people that are going to be very fixed on the idea of them having lithium ion batteries in there because they may have some robot that requires a lot of energy storage. So we made it easy for them to just swap out the batteries that are in there with their own batteries. The newest design, though, uses 3 AAA rechargeable batteries, so it gives us a much higher capacity. It also gives you the flexibility to either charge the batteries with the solar panel or just to take the batteries out and use a standard wall charger to charge those batteries and then plug them back in. And then for safety, we have a resettable fuse in there. So if more than, I think like in the resettable fuse that we have in there is an amp, if you're drawing more than an amp from a single battery, then it will shut off. And then once you've disconnected it, the fuse will reset itself. The LED square uses 3 multicolored LEDs. Multicolored because one of the great advantages of Bsquares is that when you connect 2 squares together, you're connecting the positive and negative terminals for one side. But if you rotate one square with respect to the other, you've now connected a different set of positive and negative terminals. So it gives you the possibility to essentially, in a way, tell that LED to do something different with this other permutation. So we're using multiple color LEDs so that we get something out of those different permutations. One variation of the LED just uses 2 LEDs, so when you click one side, it's a red LED. When you click the other side, it's a white LED. I think these are actually the Osram LEDs that you referred to, but they're extremely hard to find. We found them for prototyping in Hong Kong, and then could never find them again from like the actual manufacturer. And then another variation uses the RGB LED, so you can actually rotate 3 different times to get 3 different colors. When you stack them on top of each other, you get a combination of the, it might have been hard to see in the picture, but you get a combination of the red and the blue, so it shows off as pink. And then the 4th one is the Arduino square. The size of the square, we wanted to keep the size of the Bsquare small in general, so we're sort of locked into the Arduino Pro, which has all the same functionality as the Arduino Uno, but just a little bit bigger. It gives, with the design of the square, also gives you access to the shield ports, so you can plug anything in. And we have, if you saw in the video, we have a demonstration of that with the LCD shield. And then these 2 were added later on, the iPhone square or iPod square. It, by itself, it just acts like a normal dock. So you plug in your iPod. There's a port in the back where you can plug your PC into the dock so that you can sync with your iPod in this square. And it acts exactly like a dock, except for it has 4 magnetic contacts on the corners, which then gives you the capability that if you disconnect the dock from your PC, you can now attach a battery square to the dock and charge from the battery to the iPod, like all these emergency battery chargers that they have out, or connect a speaker square to the dock, and now you have a portable speaker. Connect the solar panel to the dock, now you have a solar charged radio. Kind of see there. This is also an attempt, to be honest, this is also an attempt to demonstrate that while Bsquare is, we're inventors, we're developers. Of course, a lot of the stuff that we work on, we probably have a target audience in mind that is similar to us. But we also wanted Bsquares to be more than that. So my mom is probably not going to go out and buy a solar My mom is not going to go out and buy a solar panel and a battery square and do, well, now she will, but but she may not do some more of the complicated stuff. She might not tear it apart and try and make her own B-squares because she doesn't have, those soldering skills. But she'd love for someone or for me to make her something that, interfaces with her iPhone or her cell phone. So this is an idea of creating not just things that are very niche, developy sort of products, but also things that resemble very commercial products that you see every day. And that's really important to us because we think that's really how we're going to bring people in that typically wouldn't be thinking about solar power and energy storage and things like that. Now they're going to be thinking about, now when they see their iPhone and they see that they can very easily also charge it with a solar panel, that means actually quite a lot. It means that they're now sort of entering into an area that before they thought was sort of closed off to them. And then I'll talk a little bit about the future of B-squares. So one of the obvious things to do with B-squares, all of these configurations, all of these applications, they all center on just delivering power to applications. So if you were quick and you noticed that that speaker square has a tiny little connector on the side because while you have to deliver power to the speaker to actually get the audio data, you need a third connector line. And that I don't like that. I don't want that connector to be there because B-squares is simple and it's nice in itself, and you can do a lot of things, and it doesn't require these wires and connectors, so there shouldn't be one there for data. So the idea is that just like we have these magnetic contacts on the side that keep the squares together, we're also improving the design so that instead of having this a solid wall here, we're actually going to have what we're calling side inserts. So this would be a hollowed out portion of the frame on each side, and you can actually plug in different inserts onto the sides of the B-square. So if you had an application that required data or some sort of communication between the squares, you would use a square and then have either it would come like this when we deliver it to you, or you would put it in yourself, a side insert that now has additional contact surfaces so that you can communicate with the other squares. These two contact surfaces give you RX-TX, they give you serial communication, or you can use analog. You can transfer analog data between the squares. It lets you do a bunch of other things too. It lets you do infrared communication between the squares so that it's completely wireless. I think a lot of people are going to come up with different ways that they can use sort of the versatility of these side contacts. We're also considering putting in on-off switches in some of the squares just to make it a little bit more flexible for people to turn on the internal secret circuits. It's a little bit more complicated because we do want to keep everything fairly flush so that the squares can also stack on top of each other. So we have to go through a design process of making sure the on-off switches don't hinder that. And then there's some sort of additional components or accessories that would go along with B-squares. So one of the great advantages of B-squares or examples of B-squares, when I describe this notion of rotating one square with respect to the other, you completely change the circuit and the way that it works. So I'm going to do this at the end, but I'll just show you this. So if you have a configuration like this with a red LED, when you change, the configuration turns to a white LED. One of the byproducts also of this, if these were both battery squares instead of a battery square and a LED square, what I'd actually be doing is changing this circuit from a series connection to a parallel connection. Does everybody know what parallel and series is? I don't know if it's a different word in French, but it's like the difference between if you have a remote control, you have the little picture on the back that shows you how you should connect the batteries. You either get more voltage if you connect them one way, or you get more current if you connect them another way. So the same for the same for 2 solar panels. If I connect it this way, then these 2 5-volt solar panels, they now become, in total, a 10-volt solar panel. So the same current, but a 10-volt solar panel. So now you can charge an application that requires 10 volts. If you rotate them and then reconnect them, now it stays a 5-volt solar panel. So both of them are 5 volts. The whole system is also 5 volts, but now you can get more current out of the solar panels. So
we have some graphical indication.
Yeah, there's definitely, for the prototypes we didn't need them because really it's just us who's playing with them, but for the final product there'll be an indicator of pluses and minuses. So it's probably not obvious, but sort of the trick to all of this is that each corner, the diagonal corner from it, is the same polarity of the square. So this is plus, this is plus, this is minus, this is minus. And that's how you get these configurations where when you rotate them, you're changing the overall configuration of the circuit. So those are some immediate design improvements that we're gonna do on Bsquares, especially if we meet our funding objectives. And then of course there's new squares. What other type of squares? We have 7 of them now. What other squares should we be building as soon as we get done producing the frames? Because it's sort of the beauty of Bsquares is once we have the frame and the hardware, then each additional square is just a different PCB, which is much easier to do than a full plastic, a new plastic frame. So one of the squares that we have on the list is the Peltier square, or we call them thermoelectric squares. So something that exchanges heat energy into electricity. So that would be an example of another generator square, kind of like the solar square. A USB charger square, so a square that you can just plug into the wall, and then it has a USB output on one of the inserts. So another way for you to charge batteries instead of having to charge it with the solar panel. A finger drum square, which I guess needs a little bit of explanation. The idea would be having the surface or the lid of the square is a capacitive sensor. So when you touch it, it turns on and off a switch. You have multiple squares together, connected. You have an arduino, and you have speaker squares. Then you sort of have a little instrument system where when you tap it, it turns on a certain tone or a certain sound. So then you get a sequence of different sounds playing through your speaker. A wheel square, which is a big one that people have sort of asked about, because with the Arduino, it's pretty easy to make robotic systems. So of course, one of the first things you might want to do is add the motor shield to the Arduino, but then you've got to power those motors. So having a square with small little wheels that come out of it, allowing it to roll around the room. Air monitor square, that's sort of something that we're kind of interested in, especially in Hong Kong. The air pollution is pretty bad in Hong Kong, so a lot of people are looking and developing air quality monitors, monitoring CO2, particulate matter, especially being able to walk around with something very small that monitors the pollution that you encounter on a day-to-day basis. And then Wi-Fi square, just being able to have wireless communication, which you can do with the Arduino square, but if there was something that was just embedded in a square itself, sort of opens up other applications to making other things wireless.
There could be a wireless router.
Yeah, like a small wireless router. I'm not saying all of these things. I don't even know if all of these things on this list are possible. That doesn't really, for now, it's not too much of a concern. It's just that there's a potential for it to be possible, so it's something that we definitely want to explore. There's some things I think that we're not going to be able to fit into this form factor. So in the very, very far future, then we'll be asking questions about how small can we make this, and how big should we make this for other applications, or how big do we need to make it. So maybe this needs to be twice the size to have like a small wireless router. Maybe it doesn't.
It could be a great application.
Yeah.
you know, with a lot of solar, that energy autonomous energy system.
Yeah.
Wi-Fi router for mesh working.
Yeah, exactly.
Yeah, I can imagine, for example, something like mine detectors with a Zigbee inside, with a self-routing network, the solar panel on the top, and with the wheels it's driving around. Okay, when it hits the wire, it forms up some plastics, but you save the life. Something like this one.
Yeah.
That's good.
So, I mean, this is just to say that this is what I was talking about before. Is we really want to build a community around this, because I think a lot of the great ideas that are going to come with what we should be doing with these squares. Because Sean and we've sort of built these squares, and we are in a very particular field where these squares can be very useful to us, but they have applications way outside of that sort of domain. So we need to build a community around it to get these ideas and to share those ideas with other people. And I really do think that will happen, looking at anything like Arduino or any other sort of technology that tries to access the open hardware community, the open source community. There's been, like you said, a lot of success with it.
You could look at, I don't know if you're looking for technical solutions, but you're not. But OpenWRT, maybe you know this?
OpenW.
It's a system for computer, and it could be put in something like that.
Inside that? Okay.
I can send you the link. There is some of the communities at the CMB Lab.
Yeah. Okay.
There are some two developers in the community.
Okay. Good. I think that's it. We have you guys missed it a little bit. We have right now, it's a current project. We're doing 30 days of sort of a funding campaign on a website called Kickstarter.com. This allows peer-to-peer funding. So Sean and I, my colleague on Bsquare, we worked on a lot of projects together, and as inventors, and you guys might have encountered this as well if you've had to go to funding, it occupies an insane amount of time, especially for someone like myself who would much rather be developing technology or working with technology. To spend 3 months sitting at boardroom meetings in suits talking to a venture capitalist, I mean, it's a necessity. You have to do it. Sometimes I enjoy it because I'm learning new things, new ways to interact with people, but 3 months is a lot of time. It didn't even take 3 months to develop the entire idea of Bsquare. So a lot can be done in that time. We chose Kickstarter.com, which is a fairly new thing based out of New York, where it allows peers to sort of fund your project, and it works really well. The concept is that you set a goal and you set a certain amount of time for how long you're raising funding, and you set a goal, you set a certain amount of time for the funding campaign, and you also describe what they call rewards. So they're not donations that these people give, and they're not investment. They're essentially pre-ordering a product, and it's all based off of the idea that if you raise enough funding, then you can actually produce this thing, and then you deliver on all of the pre-orders that people have requested. If you don't reach your funding goal, then the people that pledged to give you money, that money is not taken from them. The money is left on their credit cards, and you're not obligated to give them a reward. But if you do reach the funding, that money is taken from their credit card, and you're obligated to send them, what they ordered. It's worked out quite well for a lot of different creative projects. It's had some really great success with different technologies. Most of the success has been with iPod accessories, like the really big money winners have been with some sort of iPod accessory. So we're kind of excited to see. Of course, we have our own iPod accessory within Bsquares, but we're excited to see whether or not something slightly different with the ideas of renewable energy and sort of open hardware will also do as well. So yeah, you can find. We have a lot more information on the project page where you can find out more.
What is your goal of price for each square?
For funding the whole project?
No. I mean
for each square.
Not for Kickstarter, but for later.
So for each square, actually the reward prices that are on the project page are reflective of what our retail cost or our retail prices would be when we actually sell. Because we've worked with our manufacturers in Hong Kong, gotten all the quotes in. We know how much everything is going to cost. and then what the markup is going to be for the distributors that sell it. So it depends on the square, but for instance, the solar square would be about $15, plus or minus $1 or so, but about $15 for a single solar square. Same goes for the LED square. The LED square actually might be a little bit cheaper. It might be about $12 to $13. Battery square, because of the batteries, it's a little bit more expensive. It's about $16 or $17. The Arduino square, the Arduino itself costs, I think, about $20 to $25. So the total square, when it comes with an Arduino, would be around about $35. So those are the average costs. So far, I mean, I don't know, what do you think, but most people have been okay with that. They've been expecting something more. I don't know why. Like, we work with solar a lot, so I would never buy like a $40 solar panel that's this big, because I know that solar panel doesn't cost $40. So, yeah, I mean, that's the idea. We want them cheap enough so that it's actually economic for you to get a whole set of squares and do something interesting with them. The squares are not nearly as interesting by themselves or in a package of two as they would be if you have like 5 or 6 of them and you see how they play with each other. Any other questions?
What's the current funding target?
The funding target for the whole project? The target for the project is $25,000, and that's the bare minimum amount we need to get the molds made and from our manufacturer to produce the frames and then also the PCBs. So I think I checked this morning, we're maybe 35% to our funding target.
You have the 9,000 and the 30. So 350.
Great. So yeah, we have like a month left. We started yesterday, so I think it's good. We're trying to get press as well. We haven't had any press yet, so most of the people that are ordering are people that saw we had one article in Engadget a week ago. So it's either those people or people that we know. But hopefully, as word gets out, a lot more people get interested in the project and start funding.
I have a question of why this shape?
Why the square?
Yes, because I can imagine like a cube.
A tube?
A tube.
Yeah, like I don't know. I guess a square. Then when we started thinking about sort of these connections, square just seemed to make sense. It's funny, after deciding on the square, which is bad for an inventor, after deciding on the square, I haven't really thought about what other shape I would do. It also, like a tube, so it's like circular shapes.
Cube.
A cube, cube, like a perfect cube. I thought that would be too big. And then also the idea was that, so we made the size of this is approximately 70 millimeters by 11 millimeters. So the idea is that it makes a perfect cube when you stack them together. And when you stack them together, you still have the circular contact, or the circuit contact between them.
I think it's really good for adult end.
For what?
For an adult end.
Yeah.
It's perfect. My hand is just perfect.
Yeah.
Very simple to move and.
Yeah, exactly.
But I'm not sure the same for kid.
For kid, yeah.
But I think.
You think it's a bit big for a kid? Yeah,
smaller.
Yeah. Exactly. I mean, that is a question. Is what it will be difficult to do to put more stuff in it, but I do wonder, how small we can get them and how. I mean, we have all kinds of crazy ideas. Not necessarily, my dream, because my background was in robotics, and this is the first step to that is this data port that I just discussed, is the idea of, having these squares connect together and then be sort of self-aware. So you throw them into a configuration, and either one square or each square is responsible for somehow communicating with all of its neighbor squares and figuring out what the total architecture of the square is. So if someone came in and moved a square, then it could, on the fly, figure out what the architecture is. And then you go on top of that. These are magnets. We're pretty used to magnets and electric dynamos because of the work that we did with the wind energy generator. So it's not too far of a leap to realize that we place these magnets with an electric dynamo that we can actually turn on and off. And then you have squares that can attract and repel each other. So you can have sort of autonomous configurations themselves as they attract each other and connect and push each other away.
Is it totally idiot-proof?
Is it totally what?
Idiot-proof. Can people mess with it? Break it?
So
I mean, if you plug it in the wrong way, or can you manage to plug it in the wrong way?
So that's why we have the resettable fuse on the battery. You can short it, just like any other electric device, but we have that safety measure in there so that when you do short it, it shuts off with the resettable fuse immediately. It also, I don't think all of we haven't tested every single permutation because there's quite a lot, but there are a lot of permutations, for instance. So I can put these two squares on top of each other like this, and you feel the magnetic attraction, so you feel comfortable making this connection. But if I flip this, the magnets are such that now they repel each other. So you have a physical feedback that tells you that you're not allowed to do this. So there are some sort of built-in measures for preventing people to do certain things. But that again is also a trade-off because the more you sort of protect people, the more freedom. Yeah, exactly. So we have to figure out what the right balance for that is.
But for example, is it a way to troubleshoot? If you imagine you plug your different stuff together and it doesn't light, so it should be a way to know why. Yeah,
so that was along with on-off switches. That's something that we've also played with, is having small lights. Actually, one of these is a sort of advanced prototype that does have a small light inside. So we have various status lights. So like for the solar panel, we have a status light that will turn on when there's actual solar radiation hitting the solar panel, so you know that you're getting sunlight. The batteries had a status light, so that you know, one status light to tell you that you're discharging energy out of the battery, and another status light to tell you that you're charging, you have current going into the battery. There's a trade-off with that as well, because we wanted these things to be efficient as possible and actually useful as possible. So anytime you throw these switches in or any transistor, you start dropping down the voltages. And the problem that we have is that right now they're all set at or around 3.6 to 5 volts in terms of applications that they would power for a single cell. And you throw in these status lights or you throw in these transistors and you drop that voltage down so that you can't really actually power other applications. So we have to figure out a better way, basically, to have those status lights in there, but still be able to do what they were intended.
But for example, for iPhone, to charge it, you can charge it with a 3 battery? Yes, you can charge it okay.
Right.
Yeah.
You can use,
so in terms of capacity, you can have a full charge with a 3 battery?
Full charge of the iPhone?
Yes.
I'm not sure what's the capacity of the iPhone.
500 milliamps.
So yeah, you would only, the batteries that we're using, the rechargeable batteries that we will sell it with, are 1,000 milliamps.
Okay.
So 1/6. Yeah. But that being said, of course, you're not going to leave your iPhone out in the sun for a whole day. But sort of a better way of, if you're not kind of used to the values that I put up there for wattage, an easier way of thinking about it is that a single solar square will charge a single battery in a single day. So whatever application you can do with a single battery, like however much energy you can get out of a single battery, that's how much energy you can get out of one of these solar panels. Any other questions?
So I'm interested in sort of a distributed computing type of thing. But you would imagine that this would only work when you would have data ports, basically.
Yeah. So I don't know if you came in for that, but that's definitely the first thing on the list is having data ports, having some way of serial communication. There's a couple ways you can do. We don't even necessarily need the data ports. There's a way that you can send data over the power line, so you send a modulating signal across the DC.
But is it possible now to do it just with Arduino control to control
What's that?
With Arduino to encode something on the power line?
Yeah, you can do that. Yeah. Or you would. So that's what it would be. Is we would either have to add in the hardware of physical contacts here, or each square would have to have an encoder and decoder chip to get the signals that are coming through the power line. So there are a couple of variations we're looking at. Yeah. So what would you guys use? Like, what would you want to use Bsquares for? What would it need to do to? What's that?
Wi-Fi router.
Wi-Fi router. Yeah.
I like very much the idea.
Yeah.
The battery charger.
Battery charger.
Definitely.
I didn't show probably what I at times think the coolest thing. So the solar panel, one of the tech specs, we even left it off the tech specs. So solar panel, but we have this microsuction surface. So it's a surface from Japan, or a material from Japan that's microscopic suction cups. How do you say that in French? It's like ventouses. Yeah, microscopic ventouses. So instead of using like a tape or a glue adhesive that will damage a surface, you can just stick it to like windows or flat surfaces, and it's got a really strong hold, and it doesn't damage it. If it does get dirty, then it loses its stickiness, but you just have to wipe it off with a damp cloth, and then it's good to go again. It's really nice too because it's strong enough that you can hang stuff from it.
What would be fun too is to be able to interact with the square with my iPhone or my Android.
So have like some Bluetooth communication between
or at least a DK or something to make this happen, because I mean, this has some very developed sort of possibilities, but there is no not really remote thing. I cannot make something else do something for me. Yeah. And that could be an idea to make it run, to make it charge something.
Turn on and off a light or something like that. Yeah. That was, that's actually an interesting. Oh, did you want to take a picture of that?
One with the ventures?
Yeah. On this side.
Okay. And this one?
Besides the wheel that you talked about, the wheel square, what are the type of things that you can make it move?
To make it move?
Change the configuration by itself?
So I mentioned the possibility of, instead of using permanent magnets, using electromagnets so that they attract and push each other away. In terms of making it move, for the video, one of the ideas that we had before when we did the video is we were going to go into, I don't know if they're common here, but in the U.S. we have like this sort of gaming arcades, they call them, gaming arcades. We have the video games, but you also have like pool and what, I don't know if there's a French term for it, but we call it air hockey. So it's a table that has like a bunch of, air, so it takes away the friction and you hit a disc back and forth. So we thought, these are kind of like flat discs. It would be a nice little demo to show it on these air hockey tables. Of course, it's not moving by itself. Making it move also, I'm not sure.
Implement something like magnetic linear tracks, and then you can change the polarity of each second track, like a high-speed magnetic train.
Right.
And then you can move them like a
train or like a magnet. Yeah.
I think it would take much energy, but
what would be, I mean, again, some of these things, whenever I start a sentence with what would be really cool, it means I don't really know if it's possible. What would be really cool as well is not only just them attracting each other, you know, on a flat surface, that's not too hard to do. If the electromagnet is strong enough, you can get them to attract like this. But I think there might be a smart way of you being able to use configure pulses on the opposite side of the square, so that you actually attract sort of a perpendicular movement of the squares. So that's sort of another thing in the demo. If I take a couple of these.
Something like a self-holding self-mentioned, and then it moves up.
So you saw in the demo where I did this sort of Optimus, I called it the Optimus Prime configuration. You put it in a large square. What was I going to say? Yeah, I forgot what I was going to say. Yeah. Oh, now I remember. Someone asked about, as I was doing this, I almost dropped one. Someone asked about durability. We've designed for production and designed for durability. In fact, our designer, our mechanical engineer, is actually a lot more paranoid than I am usually about like the thickness of the different parts, you know, so that they don't break easily. And we've dropped these squares so many times, so in the video is nice and polished, but almost every video that I use to make the final video, at the end of it, what you don't see is someone like trying to do this configuration, and either me or Sean just completely dropping these on the floor. So far they've held up pretty well. We've got some nicks and bruises from the paint, but so far they've been pretty good in terms of durability.
Have you already broke one?
I cracked one when assembling one. I did, I think, in fact. Not from dropping it, but from pushing too hard when I was putting in one of the frames. But yeah, so far they've been pretty good. Good enough, at least, I think.
We should do one version for school, for kids to learn parallel and
exactly.
second.
That's one of the thoughts. Because it is so easy to do that, typically you have to, if you wanted to do that lesson, you have to involve some sort of rewiring or even more advanced, like soldering or something like that. Whereas this, once it's explained that this is plus, this is minus, when you connect them, you'll actually see, you know, can I draw this?
No.
So if this is plus, plus, minus, minus, I know you guys can't see this. So then you actually see that this is a series connection, whereas if we changed it, then you have a parallel connection. And that change is just rotating one single rotation, or stacking it.
I think there is a really cool step to do with this type of similarity, and something which an algorithm can understand, like a QR code. That's something between the human similarity and the QR code, and for children, they can understand what is the meaning of the square, and how to use it. And if they want more information about it, they can just check with take a picture and send the link or something like that.
Yeah. Like some type of are you talking about some type of what do they call it?
Like a QR code?
QR code?
But not really a QR code, because the QR code is not human readable.
Okay.
But imagine this is LED one. If I am a children, not an electrical people like me. So I don't understand what it is.
Yeah.
But I understand the game because it's connected. And I can have a different
simple
pictography.
Yeah.
Just to explain, this is a light.
Yeah.
And you can connect by here, like that.
Yeah.
And this pictography, if you have a phone or a computer, you can just take a picture about it
and get the full
description of the module.
That's a good idea.
And it can be more fun because you have some color and some stuff like that. And for children, I want the light module. I want the speaker module. And it defines more the identity, I think.
Yeah. And an idea I had sort of similar to this. An idea I had in terms of like kids playing games. An idea I had this morning actually as I was thinking of some other things. Are you guys familiar with the Game of Life? It's called the Game of Life. It's like a computer science program that you learn how to program. You have a single pixel or LED, and then the things around it. If there's too many of them, then this pixel or LED dies. It goes dead. If there's not enough around it, then it flourishes more, and so you get this sort of very dynamic response to LEDs living and dying, or a pixel living and dying. An idea with that was, programming. They already have, for Arduino, they have this LOL sort of shield that you can plug in, which is, like a couple hundred LEDs or however many that fit in almost exactly this size. And each LED is like a pixel or this organism that lives or dies. So the idea would be having each square having this game of life, but what happens when you connect squares together? How do the different organisms on this one affect the organisms on the other square? Again, something that can't be done unless we have some sort of intercommunication with the squares.
It makes me think something, a project really near, not the same, but really near that, and it's about square, and just a second, I forget the name.
Overlap, no?
What?
Overlap.
No, it's data type. No, shiftable.
Oh, wait.
Shiftable.
Oh, yeah.
60
or something like that. Yeah.
Shiftable is this project from, I think it's all the MIT Media Lab students.
Yeah. Yeah, a lot of people, when we came up with Bsquare, a lot of people knew about that system, and so the first thing that they ask is, well, what's
it's really not the same.
Yeah.
But it's when you speak about Game of Life and
exactly how they interact with each other. Yeah.
But I think also with basic stuff you can do many things. When I see the example of Lady Adafruit Industries with their little pencil and their little speaker on it, and they are drawing and it's making noise.
Oh, really?
Yeah, it's just a simple circuit with Arduino on side, and it's really attracting kids because they have direct feedback.
Yeah.
So for us, we know what we want, we can program it.
Yeah.
Or we know that we have to work before we get the result, but for kids, they want to have their feedback instantly.
Yeah.
And this would be something like this, because I've seen, all these little batteries with LEDs, these throwies are very in now, and I've also seen some projects with some timers, and if you put it in the sun, it's making noise like an insect.
Yeah.
It's really the basic stuff which explains kids much more in a certain age than the complex electronic inside.
Yeah.
And I think this would be a nice possibility to do this. And I imagine at my home 20 of these panels. Okay, where's the iPhone charger?
Yeah. Just
taking this and this and this, and then I have it.
Yeah.
Unless I lose the dock.
Yeah. Any other questions?
One thing I thought about when you mentioned Game of Life is that in Game of Life the life and death is determined by arbitrarily from
external rules. So if you are really emulating life, then you have to compete for resources. And solar panels is the perfect that you actually compete for sunlight. So you can have some sort of games that kids play. Each have say 10 panels, and then you have sort of a weird shaped light source, and then if they can do sort of a structure, and then they can compete for light.
Yeah. The more solar energy they get, the more their organisms sort of live.
And you can sort of score. You harvest so many lights. You get an additional one. Then you can move them around. So, and if you really can make themselves move, then you have a